In this lesson, you will learn how to graph a system of equations and then find its solution. Let's take a look at some notes and examples that further explain this concept. A system of equations is just two equations that are graphed on the same coordinate plane to see if they have a common solution. Now, what do we mean by common solution? Well, if you graph two equations, their common solution would be the point where the lines intersect. So let's take a look at some examples of some graphs where two equations were graphed and see if we can locate their common solution. If you look at the first graph, you will notice that these two lines intersect at this point here. So all we need to do to identify the solution is to write the ordered pair for that point. So the x value of that ordered pair would be 3, and the y value of that ordered pair would be 2. So we say the solution for this system of equations is 3, 2. For the second graph, you can see that the two lines intersect right on the y-axis. So again, we simply need to identify the ordered pair that represents that point. The x value of that ordered pair is 0, and that point is touching the y-axis at -3, which would be the y value. Moving to the last graph, you can see the lines intersect at the point in red. Going up to the x-axis, if we count over, it would touch the x-axis at 6. And then if we go down to the y-axis, it would touch the y-axis at -2. So the solution for that system is 6, -2. Now let's take a look at lines that never intersect so that we can understand what its solution would be. So let's scroll down. In these two graphs, notice that the lines are parallel and will never intersect. So what does that mean as far as the solution? Well, it says up here that if the system of equations does not intersect, but instead the lines are parallel, then we say that there is no solution, because the solution is their point of intersection. So if they do not intersect, they have no solution. So we will abbreviate this with NS. So if they intersect, they have one solution. If they do not intersect, they have no solution. In our last examples, number 3, let's take a look at some lines that have an infinite amount of solutions. If you look at the first graph, you will notice there are actually two lines, a longer line and a shorter line. That's just so you can see that there are, in fact, two lines. So one line is overlapping with the other, which means they are actually the same line. So therefore, they intersect at every point. So if they intersect at every point, we can't identify just one. So instead, we say that there are an infinite amount of solutions. And we can abbreviate that as IS. So again, we have three different situations. We have lines that intersect at one point in which we would identify that point. We have lines that are parallel, which do not intersect, so therefore have no solution. And then we have lines that are exactly the same, and they intersect at every point, so have an infinite amount of solutions. Let's scroll down to some further examples. If you look at example 5, we have two equations. This is a system of equations. They represent two different lines. And what we're going to do is we're going to graph these two lines one at a time, and then we're going to see if they intersect at one point, if they're parallel, therefore have no solution, or if they end up graphing on top of each other, which would mean they have infinite solutions. So I'm going to go ahead and separate the two equations. So I'll put y equals 3x minus 4 on the left, and y equals -x on the right. And I will begin by graphing y equals 3x minus 4. To do this, I want to identify the slope and the y-intercept. So using y equals mx plus b, which is the slope-intercept formula, I can easily identify the slope and the y-intercept. So notice the slope, or the number in front of x, is 3. And because we are graphing, we want to put a 1 under that so we have a rise and a run. The b is going to be the -4, which is the y-intercept. To graph that information, we will begin at the y-intercept. So we will go down to 0, -4 on the y-axis and place our first point. From there, we will use the slope to move and go up 3 and right 1, because both numbers are positive, therefore we need to move in positive directions. So let me go back down to the point at 0, -4 and go up 3, 1, 2, 3, and to the right 1, and I'll put a point. Then I'll go up 3 and over 1 and put another point. And I can do that several times. And then I will draw the line. Now it's important that you draw the line as straight as possible when you're trying to graph a system of equations to make sure your point of intersection is accurate. The second line, I'm going to go ahead and use a different color. I'll use blue. So here, using y equals mx plus b, we can identify the slope and the y-intercept. So again, the slope is the coefficient of x, which is the number in front of x, or -1. And again, the slope we want to make a fraction, so we have a rise and a run. Notice you don't see a y-intercept here, so we could put +0, which tells us our y-intercept will be right at the origin, or at 0, 0. So we will begin by graphing a point at 0, 0. And then using our slope, because the numerator is a negative, and you could either put the negative in the numerator or the negative in the denominator, but you can only use the negative sign once. So if we start with using it in the numerator, the -1 indicates a negative direction, so I would go down 1. The denominator is a +1, so that indicates a positive direction, so I would go right. So on my graph, I would go down 1 and right 1. You can already see the point of intersection. So I can continue to do that, and I can put more points. I could also go the reverse direction and go up 1 and left 1. And now you can clearly see the line. And then again, try to draw a very straight line. Now using a green pen, I'm going to show you where the point of intersection is of the red and the blue line. That point of intersection is called the solution. So let me scroll down so that we can write in the ordered pair for that solution. So the solution, if we write it as an ordered pair, for that green point, the x value would be a +1 and the y value would be a -1. Now notice below it says to prove this. So you can actually double check that your answer is correct. And the way that you do this is you would take your original two equations and you would plug the 1 into the x and the -1 into the y into both equations, and you would see if the left and the right side of the equal sign come out to be the same number. So let me rewrite the two original equations, and then we can see if it comes out to be true, and we will know if our solution is correct. So let me rewrite those equations. Okay, so looking at the first equation, y equals 3x minus 4, we're going to plug in a 1 for the x and a -1 for the y. And then we're going to see if the left side and the right side of the equal sign turn out to be the same value. So for y, we'll put a -1, x a 1. Now notice on the left side of the equal sign, there's no calculating to do. So I will just drop down the -1. On the right side, we're going to multiply 3 times 1, which is 3, and then subtract 4, which gives us -1. Now notice our values on the left and the right side of the equal sign are the same, which means so far our solution checks out. But it has to work in both equations for you to get the answer right. So if you've done everything right, it should work in both. So let's go over to the second equation, and we'll replace the y with -1, Now let's put a -1 in front of that x. So we're really just multiplying -1 times x, which is 1. Now again, the left side, there's no simplifying to do. But the right side, we can multiply and get -1. And again, notice that both sides turn out to be equal. So since we've checked in both equations whether or not the solution works, and it does, we can be confident that our solution is correct. Let's try an additional example. In problem 6, we have y equals 1/3 x minus 2 and y equals 1/3 x plus 6. Now, in previous lessons, you did learn something about looking at the slope to determine what the lines might look like. So if they both have a slope of 1/3, then what should the lines look like? Hopefully you understand that if the slopes are the same, then they should be parallel because the slopes refer to the steepness of the lines. But let's go ahead and check it out and see if it comes out to be parallel. So our slope, or our m, is 1/3, and our y-intercept is -2. When we graph this, we'll put a point at -2, and then we'll go in two positive directions, up 1 and then right 3. And we can reverse those directions and get points below the y-intercept as well. And again, we want to make sure and try and draw a straight line. Moving to the second equation, again, the slope is 1/3, but this time the y-intercept is 6. So all this means is that one line is going to be higher than the other depending on what the y-intercepts are. So let's put a point at 6 on the y-axis, which would be right here. And then using our slope, again, we will go up 1 and right 3. We will run out of room fairly quickly, so we're going to reverse the direction to get the lower part of the line. So if we were to draw the line, notice the lines come out to be parallel. So do you recall what the solution is if the lines are parallel? Hopefully you thought that it's no solution, because again, the solution is their point of intersection. So if they don't intersect, there is no solution. So let me scroll down and write in the answer. Okay, so we have no solution. And when there's no solution, we don't have a point to plug in to prove it. So in proving it, we really just want to make sure that when it's solved for y, the slopes are the same. And that's how we can prove that these two are in fact parallel. So there's no work to do for proving other than to just visually look at it. Okay, let's take a look at one final example. In this last example, you will notice that the second equation is not solved for y. So before we can graph that, we will have to solve it for y. But let's first just write down our two equations. So we have y equals 2/3 x plus 2, and then we have 4x plus 6y equals 12. So in our first equation, our slope is -2/3, and the y-intercept is at 2. So if we graph that, we'll put a point at 2 on the y-axis, and then because the slope is negative, we will go down 2 and then right 3. That way our line is going down, indicating a negative direction. And if we reverse that, we'll go up 2 and left 3. So let's go ahead and draw our line. On the right side, we're going to have to first solve the equation for y to get it in y equals mx plus b form. So to do this, we need to move the x term to the right side of the equal sign by subtracting it from the left, which becomes 0, leaving us with 6y equals -4x plus 12. Notice I put the -4x first to follow along with the format of y equals mx plus b. I will then divide all terms by 6 And then I need to reduce the slope to negative 2/3. And then I'll divide 12 and 6 and get 2. Now notice that this equation is exactly the same as the first one. So if you graph them, obviously, with a y-intercept of 2 and a slope of negative 2/3, it will come out to be the exact same line. So when they are the exact same line, how do you identify the solution since there's more than one? There would be infinite solutions. So let's scroll down and write that under the section of for solutions. So we can write, spell it out or just abbreviate infinite solutions. And again, in this part, we cannot really prove it unless we were to plug in more than one point. So if we actually plugged in 2 points where they intersect, so we could plug in, for example, 0, 2, we can see they intersect at that point, which I will put in green. And then maybe we could put the x-intercept, which would be 3, 0. So if you tested both of them and plugged them both into both equations and they worked, then you could be confident that they are exactly the same line. Although you could see that when you visually look at them, that in fact they are the same line. So that completes the lesson on graphing a system of equations and looking at the solutions to see whether they are parallel, which means no solution. They intersect, which means there is one solution in which you would identify, or they're the same line, which would tell you they have infinite solutions.